Hello everyone, this is Mr. Nuts and today we'll be continuing our beginner friendly road to SCP video series. Today we'll be looking at another HackTheBox machine that is safe. Safe is based on Linux and the difficulty as per HackTheBox is easy, but I think the box is a bit harder than easy. I don't think it's easy at all. But yeah, so safe is among the more challenging than OSCP in the TJ null list. So we'll be doing that box today. So let's just get started. So first thing what I always do is in the box, I run an auto-recon scan, and if you guys don't know what auto-recon is, it's basically doing few nmap scans at first, and based on the open ports and services, it's going to do additional scans on them. So it's like 95% of the time the scan works really great, but sometimes you have to manually enumerate things further. And another thing is you should always be familiar with the whatever commands you run as nmap and everything. You should be knowing to do things manually as well. It's like always don't rely on an automated scanner, because sometimes if it does not work, you can manually do things and try to figure out what's happening. Okay, so this is what I run first always, and it is available on GitHub. You can get it from there, and I'll be running this as root because I want the UDP scan inside this to run. So that's why I'll be giving sudo over here, because I'm running the box as Kali, and I'll be giving Python 3 over here in order to run this particular autorecon.py file. I'll be giving the target IP address, that is 10.10.10.147 in the case of safe, and I'll be giving the host switch for output directory and the scan result where I want to save the scan as. Okay, so I did already run the scan, and I'm not going to run it again. So let's just look at the scan results. First thing what I do is I always look at the full TCP and map scan, and if we look at that, we see that we get only 3 ports open. Okay, so one is port 22, that is running SSH, that is open. Obviously the version is like very latest. I don't think there are any RC exploits or something for this, so we can just leave this aside unless we have to brute force or something like that. So we have port 80 over here, which is open, and it's running HTTP service obviously, and also we have an HTTP server running, that is Apache and 2425. Okay, so we have this thing present over here. We get some title information which says it works or something. Also we get some another interesting port over here is 1337, because it is like somewhat new, and it says the service is waste. Okay, and it says open. So obviously I did enumerate this thing, okay, and I I tried to check on Google like what the service is about, but it says question mark over here, so probably it's not sure, but based on the response, probably it thought that it's something similar to a waste service. I think there's a service called waste over here. Okay, so but that's not the case, so we'll just look into it some. Now obviously there are like few request what was done over here in the service, and this is the response what we got. I know it looks a bit new and like bit different, so it looks a bit confusing, so we'll just look into this in some time. So also we get some other things as well as guesses and all these things, but I don't think there is anything interesting over here. I don't think we got the host name over here. Okay, so I don't think we have anything additional present inside this full TCP scan. So another thing, obviously we can go and check out for other things like the UDP scan as well. I think everything is closed over here in the top UDP. So we can check out the GoBuster scan, which was done by AutoRecon. We can manually additionally run it on port 80 and see if we get something. But we get only like index HTML, and there's a manual and server status. So if you just check index HTML quickly, first let's just go and check out that port 80 over here. Okay, so since we'll just leave this last resort if you need to brute force anything, but obviously there would be something over here or here probably. So let's just check out port 80 for now, and we'll probably just go 10 or 147, and we come across this Apache to Debian default page over here. There's nothing interesting over here. Obviously it's like a default page, the man page, I guess, like default Apache page. So what is the another thing is, this is what I always do in which way, that if I see some custom application or some page like this, or even on vendor specific application, I try to check for view page source on the home page itself. Okay, so if you do view page source, we see that we have a comment over here which says my app can be downloaded to analyze from here. It's running on port 1337. So probably it looks like some comment over here which says port 1337, because which was open over here, right? So some application can be probably downloaded from this server which is running on this particular port. So we'll just look into it in a bit. So obviously we'll just check out that manual itself, and I think, yeah, so that's what it's calling the manual page OS. If you go to manual, so this is the thing, what it's calling for multiple things, I guess. Okay, so if you just look at the manual as well, so this is that manual other page which is referring to, I guess, so over here, which we saw, right, in the Go Buster scan. So this is that page which is present, and I think you can access it from here as well. Yeah, this is the way we can access the manual page. Okay, so that's it. I don't think we had anything. Obviously you could run, like, we could actually go and run a small Go Buster scan over here. So you can do that. And also there is another port, that is 1337, right? And in the previous videos also I have mentioned that whenever you see a non-standard ports, which is not familiar with, like, the version or something is not familiar, try to connect, do two things, important things. One is you can check it from your web browser itself, that hey, can I connect to this particular port. Does not mean if it's not 80 or 443, that does not mean you cannot check it in web browser. Just check it in web browser, or do a telnet or netcat and check out this particular port if we get something or no. So what we'll try to do is we'll just try to quickly check out for this particular page over here, and we get something over here. Okay, so as it was mentioned in the comments over here, view page source, it looks like my app can be downloaded to analyze from here, which is running on port 1337. Okay, so initially I thought, like, whatever request we make, that ends up over here, so echoes back. So I think this is doing a get request first when we load the page, right? When we load it, obviously it will send a get request to the server target machine. So that's what it is coming, I guess, the first line. So if you just see it quickly, if you just enter something like mutated nuts, and if you go, so this is what it's coming over here. So first I thought that probably I was trying to Google, and I thought that there'll be some issue with HTTP response splitting. Okay, so I thought that would be the exploit over here, but that was not the part. In short, it's just, trying to echo whatever is written over here. So if I type who am I or something, so I thought, like, probably if we get this application, we'll get to know the source code or something, and we can achieve remote command execution or something over here. But I was wrong. So obviously just leave this thing aside. It says what do you want me to echo back, and obviously it's like some system time over here, and it says 0 users logged. It looks like some time, right? Anybody would guess that it's some time over here. So if you refresh it, obviously that's the time present over here. Okay, so this is what it is. It says up 37 minutes and load average 000. I don't know what that is. Let's just ignore it. Okay, so what we can do is, next thing, we'll look into this thing, same thing in netcat. Okay, so we can just do that. We can just do nc, and we can just enter the IP address, because sometimes in netcat and web browser there are things working differently, so why not try both, right? So until it's an actual web application present in the web browser, so we'll just do 1137 over here, and we see that we get the same thing. Only thing is we did not get that echo back thing over here. So obviously it says there's some interactive thing open. So what we can do is we'll just try to type who am I. So in short, that echo back comes later with who am I, whatever I entered over here. So this is what would happen every time whatever I enter. So if I enter mutated nuts, so it's gonna echo back the same thing over here, and it closes the connection by itself. I'm not pressing Control C or anything, it closes by itself. Okay, so I think we have done, like, the initial part of what we can do. Second thing is we can just try and get that particular file now over here, my app file, and if you just check out in this web browser over here in the Apache web server, because it was present over here, right behind this source, and it says you can get it from here to analyze. Okay, so we can do my app, and we get this particular file. So what we can do is we can just take this thing and probably use wget to get this particular file. So we'll just use wget and this particular file to get it in our system directly in our current working directory. Saves a lot of time and trying to save, copy, paste and everything. Let's just go back to this my app file, and what we can do is we can just run a file against it. So we'll do file my app, and it looks like it is some 64-bit LSB executable, and there is, like, I think it's made for Linux itself. Yeah, so it's some Linux executable which you can execute. Obviously we can try executing it, but first thing is, before you try executing it, we can probably check out for other things over here. rather than executing anything. Okay, because the thing is, if what if it's malicious in nature or something? I know that HackTheBox, obviously there wouldn't be some exploit, which would crash your system or something, but it's always good to be safe, to see what's inside it before you run it. Okay, so what we can do is we can use Jidra. So there's one application called Jidra, where we can analyze things, what's present in this file, and decompile, not decompile basically, yeah, but you get a lot of information present over there. So let's just see what this application is. You need to install Jidra if it is not present, but to do this particular box, I don't think you require Jidra as a must, just to make you all understand like what is actually running probably. So that's why I will be using Jidra. I already have it in this box. I've used it for multiple other HackTheBox machines. Okay, so I'll be using for this as well. I don't think it's there in any of the videos, like my video especially, but I had used it on few 2-3 boxes I guess earlier. So what we can do is we have file my app. We can just locate for Jidra run. So this is where my Jidra file is present. So I'll just try to run this particular file. So just try to run it. Okay, my bad. So we'll just try to run this particular application. It's actually an application which is going to decompile things and everything. So it's going to be a bit useful for us over here just to understand what it is. So we can just probably do new project, non-shared, okay, save, exploit, okay, probably go back, my bad. Okay, so this is the directory which we want to be in, and we'll probably just select this as project working directory, and we can name the project probably as safe. So finish, and we have this particular project safe over here. What we can do is we can just run this dragon like thing over here. So just open this thing, and we says decompile. So obviously it's like a decompiler, but it does not actually reverse engineer and print out the actual information over here. At times if you have C hash applications, it will do that, but here it will try its best to analyze each and everything. So once you open this, you can do open file, save, and sorry, you need to open a project, you need to drag a project over here. So what we'll do is we'll just take this my app application, put it to this code browser over here, and leave it. So obviously I just dragged this thing. It says something like this. Just select OK. Loading language. Waiting for please save. Yes, I'll just like to analyze it. You can probably select all over here. Okay, but two things are mentioned as red. So I'll just probably leave it as it is by default. I'll just do analyze, and probably we got that, all the registers and all these information over here. So what we can do is we can look at functions over here to see what all functions we are dealing with. We can look at this main function over here, and we see that immediately we get something like, I'm not sure, don't think you can zoom it. Okay, so I hope you all can see it's a bit tiny, like as in the font size a bit low. So over here there are multiple things like, first thing is this particular function is calling some system command over here which is uptime. So already there's a string present over here. It's not that there's some other function being called to generate this string. So and over here it says like what do you want me to echo back. So now if you try to relate it to what we saw earlier, okay, into like our particular netcat listener over here, and also this page over here, if we look at this page, so this is like system uptime. Okay, so that's what it's running, I guess, first a system command. And first I thought like probably we could inject something over here or try to manipulate something, because it's getting this particular command or something. No, sorry, try to manipulate something over here in this echo thing, but that does not work that way. Okay, so you cannot do anything over here. And we have this printf, and it says like what do you want me to echo back. So obviously this is the same thing what is present over here. What do you want me to echo back? whatever we enter, supposedly this thing, and in netcat we enter like who am I or mutated nuts, so that thing is going to come over here, it's going to get it from this, and it's going to put it over here, and the character says 112 over here, character max length I guess 112, and return 0. So obviously this thing is just like present like a function over here which we can enter. This is how it works. So another thing is, since the character limit is mentioned over here, so probably it looks like it can be prone to buffer overflow or vulnerable to buffer overflow attack. So we can just confirm this buffer overflow attack, and we can see how we can go about with it. So first thing, whenever you want to confirm that buffer overflow is present, you need to send a huge character list. Okay, so over here if you run this particular netcat again, okay, so if we run this particular thing, and if we just write uh, who am I, so this is what we are sending to echo back. So this is who am I is coming over here, here, and all these things, right? And it's going to output us whatever it is. So now what we'll try to do is we'll try to send a huge number of, like huge amount of, as in it's like a long list of characters, okay? So that the application crashes and we confirm that buffer overflow does exist. So what we'll try to do is, first thing is that we'll just locate Python. No, sorry. We'll just use Python 3 directory. So do Python 3 C for command, C switch for command, because you're running it on the terminal, right? So we'll just do print, and we can print multiple A's, okay? So we can do that. We'll just print 100 A's, and that's it. So if we do that, if we hit enter, so it will print 100 A's for us. So we'll just copy this, and again we'll run our netcat connection over here on 137, sorry, and we need to enter something like who am I, right? Some text. So let's just paste it, and we enter this entire command, but we did not get any buffer overflow. So what we can do is, next thing, we can generate another command over here, that is probably enter 200, and we get 200 A's. So copy that, and also we'll be entering the same thing for netcat as it is mentioned over here. So we'll paste it, and we do not get anything. Sorry, my bad. For some reason that echo thing did not come. I'm not sure if it got connected or no. So if you send 200 A's, it does not show anything. Okay, in short, it does not show anything. Obviously, we would not get any error or something, but it looks like we did not get what do you want me to echo back. Okay, so earlier we did get what do you want me to echo back, right? Over here. So it looks like buffer overflow is present since we just added it over here. So what we can do is, next thing, just add this thing, enter who am I, and it says echo back. So obviously it's a bit different. So what we can do is, we have this application now, we know that probably buffer overflow is present over here. What we can do is just run this my app. I think we'll have to chmod for permission. My app, we can just give an executable permission over here. So we'll just do chmod 7. So we are adding, this is 6 probably, 4 and 2. So we'll just add 1 over here for execute. 744, we'll just leave this as read itself, and we'll be adding this my app over here. So we'll do that, and if we look now, so it's RWX over here. So I hope you guys are familiar with this thing, okay, file permissions and everything. This thing has to be like, muscle memory to you. You should know what it is. Okay, so if you guys don't know, obviously, then it's like nobody comes, nobody is knows each and everything from the start itself. But obviously, this is one thing you should be knowing if you want to clear the exam or everything. This thing should be like in your muscle memory. Okay, so what we'll do now is we'll just try to run this my app file, and we'll just try to run and see. It directly says what do you want me to echo back. Okay, so this was like, obviously we got the response later, right? So it says what do you want me to echo back. So if I enter who am I, it'll probably echo back who am I itself. It's just echoing, doing nothing else. Now what I'll try to do is, I'll use my app, I'll use this 200 200 A's, because in 100 A's we got echo back, but in 200 A's we did not get any echo back over here as seen in these two commands. So let's just enter 200 A's, If you do enter, we get segmentation fault. Segmentation fault means that buffer overflow is present over here. Okay, so that means we have confirmed buffer overflow is present. So what we can probably do is we can just enter something like my app buffer overflow confirmed. Okay, so now once buffer overflow is confirmed, next things you have to do is how do you, at what point that particular buffer overflow is being overwritten or something like that. Okay, so what we'll try to do is we'll be using another application now, that is GDB. So if you guys do not have it in your system, you can use it. We have used it for our previous box, that is October, I guess. Yeah, it's October. So in October as well, we have used GDB and GDB PEDA. So that means PEDA, there's a module which is used in GDB. So it's like, yeah, immunity debugger or something like that, along with Mona module that way. So you can get it on Google, like you can go and get it, like the GDB installation as well as the PEDA, because it's very useful over here, because I don't think without that you'll be able to do it. But otherwise you require some of the other, debugger or something like that. So we'll be using GDB. I already have it installed in my system. As I mentioned earlier, like you can go and get it installed, GDB and PEDA both. So probably we'll just run GDB with Q switch, and also we can probably just enter my app. I think we can remove the Q switch itself, but let's just run with this and see. Okay, so we did come over here, enter, and over here if we entered and we see that we have PEDA as well, because I have PEDA installed as well in GDB. So two things what we need to do is, first thing is we need to check the security protections present in this particular my app file. Okay, so what we'll need to look at is, first thing is security measures, buffer override location. Okay, so we'll do this for now. So we'll look at security measures. So what we can do is we can just do check sec. So that is check security, I guess. So let's just hit that. It's a command, and it says over here NX is enabled. So if NX is enabled, that means no execute. That means you cannot execute anything from the stack. So our normal stack based buffer overflow is very simple. Okay, so as in if you override this particular buffer, and if you write the stack, you can execute commands directly from the stack. Okay, so that is obviously our buffer overflow. It's it's a big important topic in OSCP. So stack based buffer overflow, so we have that thing. We can obviously execute commands from the stack directly if we write to the stack. But here in this case, even if we write to the stack, we cannot execute anything because NX is enabled. This is DEP. Okay, so data execution protection. So this is going to be, since it's enabled, it's not going to allow us to execute anything from stack. So this is a big, a hurdle in our particular way to root. But yeah, this we can overcome this by, and somehow in the October box we had seen that we had done return to LIBC attack. Okay, so you can probably check that as well. But the thing is, we do not have system access over here. For LIBC, we require the LIBC location and system location as well as bin sh location in the LIBC library. Okay, so if you all want to know more what I'm speaking about, you can check out the October video, like October, that's the box name. So you can check out for that. And also it says rel row, that is partial. So that means it's not full. So if it is full, then probably we cannot execute something. But if it is partial, there are like the GOT tables are involved over here. We can probably execute and probably exploit. And other things are disabled over here, canary, fortify, pi. Okay. So what we'll try to do is, next thing is that we'll probably look for the overwrite location. Okay. So we'll just run our particular file first, GDB PEDA. And it says, what do you want me to echo back? Warning not running. It did not let me enter any value as seen earlier, right? Over here, if you do who am I, like obviously over here, if we did run, it was like, hey, you know what, I'm waiting for you, enter some value. But if I just run, it's not going to let me enter any value over here. So that means I have to set some mode, that is a parent mode. So what I have to do is set follow fork mode, that is parent, and then if I run it, okay, probably I have to exit it and then I have to run it again. So let's just do that. Let's just quit. Let's run GDB again. So let's just set that mode. Now run it. So now it got, we got this particular thing echo back, and probably we can enter who am I. Okay, so it echoes back who am I to us, and it obviously exited. So what we can do is we have that 200 A's, right? So I think we'll just close these things over here. We do not require it anymore. So let's just close that and open another terminal over here probably. And we can call for that Python 3 print. So probably we can enter something over here itself so that it's easier to follow. So we'll just enter Python 3 C print A 200. So it will actually print 200 A's. So we'll just copy this thing and run this file now. And now we will probably enter this particular command. So if you do that, obviously we get that segmentation fault and we get all the registers and all displayed over here. So if we see that we have written RSI over here with like 200 A's, we have written, no, we do not have anything on RDS, sorry. We have RPB written over here, that is A. We have RSP written over here, that is A, and so many times. So this is like a 64-bit, application. And this whole thing is for 64, the buffer overflow we are doing is for 64-bit. It's not even 32-bit. Okay, so in 64-bit, it's like, these are, is like same like the E in 32-bit. Like EIP and your ESP, okay, EPB. So all these things are the same as your E register in 32-bit. So now since we have, actually achieved buffer overflow, what we need to do next is we need to find that location where we are writing RSP, okay? So that is like ESP probably where we are writing this particular thing. And what we can do is we can just try and, get that pattern creating. So GDB as well, like in Metasploit as well, you have that pattern create and pattern offset. So in GDB, you have it built in as well, GDB peda. So we'll be using that itself. So we'll just create pattern for 200 because we know at 200 we add a crash over here. Okay, so I know it may be for new comers. So obviously these things would be like very new and it may be very confusing, but I'll try to make it as simple as possible probably. But yeah, just ignore these things for now. We'll just go step by step and see what can be done. Just consider we have 200 A over, sorry, we have an A over here. We have like repeats 200 times in RSI as well as RSP over here. It says 80 times and repeats 152 times and so on. So let's just ignore all these things. We'll just create pattern create now. So pattern create is going to create like non-repeatable characters. So it's going to let us know at what location we are writing this RSP over here. It will be useful later on. We'll just see what it is. So we hit enter. We get a pattern create done over here. So let's just copy this thing. We don't require the commas. We'll run this particular file again. And once we run it, it says, what do you want me to echo back? So obviously we'll copy this thing, right? So we just paste it over here. And we obviously get buffer overflow again because we had created pattern create for 200 characters, like 200 character long. So what we have is RSP over here. We need to check the location of this particular thing, okay? What location this thing is present at. So let's just copy this thing and we can just enter over here as pattern offset to know the location where we are writing. Okay, earlier we obviously pasted a long file, right? As seen over here, we created a long file. Now we want to know the location where that J is. So probably something like this thing is starting. Obviously you can try and do it manually, but we have a pattern create, pattern offset tool, so it's much better to do it this way rather than doing it manually. So we'll just do pattern offset and we'll copy this thing over here and paste it. So we see that offset found at 120. Okay, so now if we found actually did find this at 120, that means at 120 we are writing the RSP. So in a cherry tree we'll just write, we'll probably mention over here NX enabled. Okay, and we can mention override location RSP written at 120. Okay, so what we'll try to do is we'll just create another Python A's over here. We'll just create 120 A's for now, and then we'll add another B over there. So we'll add like 8 B's over there. Okay, since it is like 64-bit, we'll require 8 B. So because 64 is 8 bytes that way. So yeah, 64-bit is 8 byte. I hope you guys know. Okay, so we'll be having B over here. Just enter B. You can mention any character, okay, as long if you all want something like, if you all want, you can enter M as well, initials, whatever you all want, just to make things better. So we'll just enter B over here, and B, and we'll enter it 8 times. So that is A 120, which we had over here, that was 200. Just scroll this little on top, and we'll have B, that is 8. So if we see over here, obviously we got like around 120 A's, and we got like around 8 B's over here. Okay, so that is like 8B over here. So we'll just copy this thing. Now since we have that offset at 120 RSP, so RSP is being written like from 120. So let's just try to run this file again. So in order to run this file, just press R, as we had seen earlier. Run this file, and now paste this thing over here. Okay, so once you paste this, hit enter, and we see that we successfully write RSP. Okay, we had entered A over here, right? Successfully we entered B now. So all these 4B, whatever we have written over here, is written over here. So obviously you can change it to like probably C or something. It's gonna enter that C value in RSP. In short, we are successfully writing RSP. We have control over RSP. So let's just do that again, just to to make things easier to understand. So if you do C again, so that means RSP is writing with whatever value we are putting after this particular thing over here. Okay, so we did that, and we could actually write RSP. So we are writing RSP written at 120. So we have confirmed that as well. Now what is the next thing is, we need to check out other things in this particular box. Okay, so we'll do this particular box step by step. Since we have NX enabled, as we had seen over here, we cannot do, we can just probably mention, cannot do stack buffer overflow. And since we do not have access to what you say libc library, since we do not have in October system, like in the October machine we had access to the target machine. Here we just have that file. We do not have that libc library, because my attack machine's libc library address offset would be different than that of the target machine. So we have to guess that. It will be a big thing. Okay, so guess this thing each. I think brute force also would take a lot of and huge time. Okay, sorry, so I don't think that's going to work. Another option is you can use your ROP attacks on buffer overflow, return oriented programming. So in short, return oriented programming, what it's going to do is that these things are registers. So we'll be calling each, like, 1 or some other register over here, and we are going to probably, whatever we call over here, we are going to execute some command or malicious command, so that we achieve, our main goal is to get remote command execution done. Okay, so now since we confirm two things, that in order to successfully exploit ROP, we confirm that we can write this thing, right? So this would probably be our first step, that probably mention as write location. We got these things over here. Another thing is that we can probably check for ROP attack vectors or some different functions which are present inside the box, which we can call. Okay, so what we'll do is we'll just quickly look at that. So we'll just exit this GDP peda, because we need to restart it. Otherwise, if we load functions, it's going to be a big mess. So I don't want to do that, because it's going to be a long list. So let's just quit this and run it again. As simple as that. So we can probably enter that set parent mode again. Okay, and now we can do info and functions. So whatever functions we saw over here, right, these things over here, is just gonna display us the same thing over here itself in GDP peda. This was seen in Jidra. We are doing it in GDP peda over here. So let's just do info functions, hit enter, and we get something like, obviously we have multiple function that is in it, puts, system plt, printf. So system plt is probably nothing but the one which we saw over here, this system command. And if you look at the address 40116E, so is it the same one? It's something different, I guess. I don't think it's the same address. System, call system, I'm not sure. Probably there'll be some other system as well. I'm not sure, but yeah. We'll have system over here, I guess. Yeah. So there are two systems over here. So this is the one which we are looking for, this system over here. So system address. Okay, so this is what it is present. So system command is present over here. So this looks a bit interesting because we can use this for ROP attack to, probably execute a system command. Okay, so what we can do is we can just save this entire thing over here. ROP attack we can mention, and we can just mention system offset, and we can mention this thing. So obviously we do not require the zeros mentioned over here. You can leave it if you are comfortable, but we can remove that as well. So you can just enter this add system PLD. Just keep it for reference because we will be requiring it to cover and actually perform ROP attack. But another thing is we need to get some vector. Okay, I know it may be a bit confusing, but let's just probably go with the flow. So obviously there are multiple other functions over here as well. We have the main function 2 over here. Let's just check main function. In order to check the main function, which is this main function over here, we can try and add disassemble main, and we get that main function disassembled. So obviously there are registers over here. We do not have that values and everything which was present in the decompiler, but we have the registers, how it is working, and how the things are happening, like move RSP to RPB is happening and all these kind of things. And we see that system command present over here, the printf, that is probably the same as this. Then we have gets and puts, right? So over here also we have gets and puts. So that is the same function. Also we see another function over here which says test. So let's just look into that test function, and it looks like the test function is unused. So this probably we can use this particular function to overcome and achieve our buffer overflow. Okay, so we can use that because it looks like there is some jump vector to R13. So R13 register which is present over here, if we call this test function, okay, so when this test function executes, just consider this test function like probably something like, so normal test function which says something like test, and it will probably mention something like first step it will mention like create database, okay, then it will be like update database, and then it will be like delete database, something like that, right? So in short, that's the same thing. I know it's a bit irrelevant over here, but I just want you all to understand that this test function obviously has few things present in the registers what it is doing. In short, later on it's gonna do a jump to R13. So whatever is present in R13, it's gonna execute that command. Okay, this thing. So if by chance it says jump R13 directly over here, if we call the test function, if we do not call it, obviously this thing would not work, it would not run because it looks unused. So this R13 which is present over here, we can enter the system command which we saw earlier over here, system PLT, which is being called over here as well. So yeah, this is the command which you are calling over here. Okay, same thing. And this is obviously the location would be different, but this is the actual one which we saw in Jidra as well. Okay, so we have, if we add something like R13, this thing is going to be like jump to R13, that is a system command, and probably we can give some argument over here. Okay, so now what we'll do is we'll just update this ROP attack. We did find a new test function. So what's the location of the test function over here is this thing. So we can just copy this and probably just mention test function offset. Enter this. We can remove these zeros over here. Okay, so we have this particular thing over here for test. So we can just mention test. And if you see, just look at these last lines because others are zeros. So 401152. And in the test first line itself, it's 401152. Okay. So that's how it is. It's going to call that test function. And what this test function is doing is, we'll look into this in a bit, okay? So we'll just probably copy this thing for future use. So let's just do copy selection, and we'll add another subnode over here which says test function, and we'll paste it over here just to understand what it is probably, and we can just enter test. Okay, this is what it's doing. Okay, so in short, now we got a few important things. We got the test function offset over here. We got the system offset over here. Now we saw that there is some jump 13. I know it's a bit confusing, but jump 13 we saw over here. So if we call this test function, okay, if we call test function after this override RSP or something, so in jump 13 we can add this system value, but we need to add the system value, right, to this. Okay, just probably mention like to do find a way to add R13, sorry, system to R13, that way. Why we are adding system value to R13? Because as I mentioned earlier as well, we are jumping to this R13 register. So what we'll try to do is, we'll just try to set our breakpoint first in the main command over here. We'll just do that. It is important, otherwise that ROP search would not work. You can use ROPR, but I do not have it installed in Kali. So I'm just using ROP search, which is already present in GDB PEDAR. So ROPR is obviously that it will show you where all this R13 register is used and where you can probably enter some command over there. Okay, so we'll be using pop RBP. So if you enter this pop RBP, so next command whichever comes, suppose if you enter this, you call this function, so the next value would be the RPB value which you can enter. Okay, so what we'll try to do is, we'll just try to look at, we'll just set the breakpoint first, break at main. So that is the main over here. So we'll just do that, break main. So breakpoint set at main, that is this. I'm not sure why is the address different, but yeah. So set the breakpoint at main, and then probably run this particular thing. And once you do that, it breaks over here, right? So what we can do is, we can just do a ROP search, and we can just enter pop R13, because this is what we need to pop R13, and we see that pop R13, we just find one thing, that is this particular R13 over here. Okay, and obviously there are other unwanted things as well, like R14, R15. We do not require it over here, because in the test function I don't think R14 or 15 is present, R13 is present, so that's why we require this. So we'll probably just copy this entire thing. Also the location, so location is more important, but we'll just copy this entire thing just for reference what we need to do. So we have another thing over here, that is your pop address, that is this particular address over here. Okay, so this is the address which we are looking at, and we have pop 13, pop 14, pop 15, and return. So this return is going to go back, and that's how after this return we'll be calling this test function over here. Okay, so in short, we got all the parameters. I know this may be a bit overboard or something like that to understand, but it's not very, I know the box has a low rating as well, but I think I really like this box, because I got to learn a lot of things and a lot of aspects over here, and it is, once you understand it completely, it's like really good to know box. Okay, so obviously we have this few things present over here. Okay, so slowly we'll just look and see how we can properly exploit this thing. Okay, this pop R13. So in short, if we want to have this pop R13, we have to replace this R13 like to system. So this is our end goal. We are entering system over here. We'll probably enter blank values, and for system to get that command. Okay, so obviously when you do like something like Python, and you're giving some command, right, to probably print, you're giving some command over here, right? My bad. So we are giving some command over here using Python, so just consider this as system, and obviously we need to give some command over here, that is probably like bin sh. So in order for this R13 to execute, like once it executes system from R13, it requires a command in RDI. So RDI is the first argument which we can supply. So I'm sure that like it will be a bit confusing, but RDI, so that system command over here in R13, if we write it to R13, it will read that argument, that is your bin sh probably is, okay, we are calling bin sh, it will read it over here in, sorry, not RIP, my bad, it will read it from RDI. So in short, we need to write RDI as well. And now let's look at the test function over here. So what this entire thing is doing is, if some way we can write RPB, okay, we'll just look into that in a bit. So it's going to push it to the top of the stack, and probably RSP would be written over there, okay. And I know you cannot execute anything from the stack, but RSP would be written if you do this. We'll just go step by step and see how it would be written. Then we probably have move over here. So move command, what it's going to do is, it's going to move this RSP, whatever value is there in RSP, okay. If RSP has a value which says like mutated nuts, okay, just consider. So it's going to move mutated nuts value to the RPB register. So this is probably like redundant because already RPB had bin sh, whatever we write over here, RPB already had it, and that's how it wrote to RSP. And if it's writing back over here, it's just consider this as I'm pushing mutated nuts, then RSP has mutated nuts. Now RSP will give mutated nuts value to this RPB, okay. And now RSP over here again in the next register, next increment step, is going to give this value, whatever is present in the RSP, to RDI. Okay, it's going to move RSP value to RDI. So in short, when we do jump R13, it's going to take the system command over there, which we saw over here. The system command which we'll call will probably take the first argument, that is RDI. So if we write RDI like something like bin sh and system is calling that, so we'll have a shell. Okay, so this is how we have to work our way through the exploit. But first, another thing is we need to find the location of RPB, write RPB. So in write thing we can probably mention as write RPB. Okay, so we need to write RPB. So RPB is usually before RSP. Okay, so RPB will be before RSP. So in short, we are writing RSP at 120, right? So if we probably RPB register, so it's like 8 bytes. So we'll probably just minus 120 by 8 and try to add B's over here. Okay, and then add C properly. So we can just enter this thing. We'll add 112A, because why? 120 minus 8. Because we need to write the register over there, so that is 8 bytes, so we do that, and then we'll enter something like B, and also something like 8 bits, sorry, we require 8 bits, so we'll write B, so that we write the RPB register, that is over here what we are looking for, right, RPB. And over here, if you want to see that we have to actually write RPB over here, then we'll come to RSP. Okay, so we have this, and C you can mention 8, or probably you can just mention anything like 40 or something, okay, just to see what happens. Okay, we'll go step by step and see what will happen. If you're till now, if you guys still found it like little confusing, it's okay, we'll just see and increment things one by one and see how the registers and everything is working. So we'll see step by step each and everything. Okay, so what we'll try to do is, we have this thing over here, let's just copy this thing, and I don't think since we already got that pop R13 over here, we'll be using this particular location for this pop R13, which is going to execute the entire thing, by the way. So, and it's going to return in the end. Okay, so what we'll try to do, we'll just quit this now and start it again, my app, and we'll enter that parent mode. Okay, we'll run it, we'll copy this thing and we'll paste it. So now if we look at the registers over here, we have obviously written the RSP, that is C, but before that we have written the RPB, that is 424242. Obviously that is like B. So why? Because 120 plus this thing, okay, so we'll actually write this RPB. So that's what I said, 120 is the RSP location minus 8, RSP location is 120, minus 8 is the RPB location, okay. So I hope it's clear that how we are writing the RPB over here, which will be crucial for us over here to move this RPB to RSP. We'll look into that in a bit, okay. So that's how it's done. We have written RPB as well. So we can probably mention over here at done, something like that. Done at 112. Okay, so that means we have written RPB at 112 location. Okay, so now we have all these things present over here. What we can do is we can go to the final step of probably writing that particular payload. Okay, so we'll just probably try to write that, and to write that payload probably we can just mention something like exploit.py, and you require a module called pawn tools. Okay, so you require that pwn module in Python. So we'll just do user bin python 3, and we require from pwn import all. So this is what we want to do from this pawn tools. We are going to import each and every, what you say, each and every modules or whatever the files are. Okay, so now slowly we'll write the thing. Okay, so first we'll just comment, we'll just make it simple, and to understand, we will override the buffer, override the buffer, and then we are entering the thing. What we are entering is, okay, we'll just override the buffer over here, and we can probably enter the first thing, that is your junk values, that is this A. The starting A's don't matter, you can enter anything, it's just junk value which you're filling to reach RPB and RSP respectively. So what we'll try to do is, we'll just enter, my bad, so we'll just enter junk characters over here. We can give the equal to sign over here, and we enter B over here because B is for binary. So just enter this B, enter a value over here, that is, you can enter A itself, and you can enter this as 112. My bad, 112. Okay, so this is what we did enter over here, 112. So this is nothing but, this entire command is nothing but the starting 112A is over here. Okay, so this 112A, which will probably become before this RPB. Now second thing is, write the RPB value. So in RPB, what has to be present is your bin sh value, because why? As I mentioned earlier as well, RPB will probably, if we do push, and it will be, the RSP value will display as RPB. RSP will then push that bin sh value to to RDI. Then when we execute system command using this, it's going to execute that bin sh. Okay, so let's just do that. Over here we can just enter that bin sh, just enter bin sh probably, bin sh, and we enter the same thing as binary, and we will enter the text as bin sh. So I hope you guys know what bin sh is in your box. If you do, which sh, it will show you, obviously this is user bin sh, but most likely it is always bin sh over there. So we can do that. So we have bin sh over here, and what we can do is we can just add a null byte over here so that we can terminate ask string. Okay, so if we just enter this thing over here, so that's a null byte which we have added. Okay, so in short, what this is going to do is, now since this is 3 and 7 characters, I guess, so there's one 8 character, so we are writing something which is, there's a limit, if suppose there's an input, you have to enter value of 10 characters, but you only have 5, so probably that's why you are giving that null byte away, so that it knows it's ending and it will go to the next thing, that is probably the RSP. So over here it is we'll just mention something like junk value, write RPB with bin sh, because it will write RDI later. So we'll just look into that in a bit. Then now once we have these things over here, now we'll enter another thing that is important in the RSP. What should be present is your pop register, the R13 which you saw. So that's the pop register which is present. So that is this thing over here, pop address. So we need to get this thing over here. So pop R13 will do that. Pop address, just mention address probably, and you can enter this thing, but you need to use that P64. It's from the pawn tool, so that it will properly print out in actually, like, since it's non-ASCII characters are not printable characters, but it will properly print out hex values that way. So that's why you have to use P64 over there. So it comes with pawn tools, I guess. So that's, we'll just copy this thing, the location pop address, and we'll paste it over here using P64. So do that, that's it. So this is that write RSP with pop address in order to get this pop address thing working and running. Okay, so that's why we'll probably just enter pop address over here, because after these things over here we are overwriting the RSP, right? As seen over here, after the junk characters and this RPB, we are writing the RSP over here. So that's why we are using this ROP attack over here. So as we saw, we are writing the RSP with C's, that is after the B's, that is after 120. Okay, we got that thing done, and I don't think we require Jidra anymore. So let's just close it. If you can just see the test function, we do not get anything over here. It says unrecoverable something something. So let's just leave it as it is. We can probably close Jidra. Don't save. Don't think we require it anymore. Just need to analyze thing. That's why we used it. Okay, so we have this ROP attack. So we had that pop address. Now next thing we require is what is pop doing? Pop is first getting this R13, then it's getting this R14, then it's getting R15. So when you call this pop address, you require to enter values of R13, you require values of R14, and you require values of R15 as well. Now obviously you all may say that we can enter bin sh over here. That's not going to work, because pop to R13 we are going to enter system command. And for system command, to give system command the argument, we require that jump R13 and that RDI. We'll look into it in a bit. So let's just go step by step. We have pop address. Now we require another thing as the system address. Okay. So we can just mention system address. We can do P64, and we can copy paste the system address, which we actually did find earlier, right? We had checked it earlier in the video. Okay, so we'll be like find system address. So here we are not doing anything else, we're just looking into it, and we'll be writing, okay, just one thing, system address, right? But we are writing system address to pop R13, so we'll mention that as well over here just to understand better. So pop R13 system, just mention pop R13 system. You do not require address, it will be too long. Okay, we'll be writing system to R13. So this is what we will be doing over here. Okay, and then later on, after that, we will add these two parameters also. We cannot ignore it. If we ignore it, it's not going to work. So we need to enter something or some null characters. So we'll just give 0, 0, but we do not require anything. Here we need like system. We can probably give some another system over here and ask like, who am I? Something like that. Just I put it. I'm not saying, but I don't want to go that part. But we can just leave it as it is. Keep it simple. We can have pop R14, R15 fake, or we can just keep it simple to make it understand. We can just enter pop R14 fake, and we can enter P64 over here, and we can enter 0x0, that is null value. Okay, 14 will have null value. Okay, I think that's good. I guess R14 will have null value, so that we do not want to enter anything, we just want to ignore this thing. It's as simple as this command is as simple as you have to add 3 numbers. But I only want to add one number or something like that. Or probably you have to find a square root of numbers. Okay, so you can enter 3 numbers over here in the function. So I'll probably enter first, like I want to just find the square root of 25. So I'll just enter 25 over here, and then later on after that I just don't want any other number. I don't want to waste my time. So I'll just enter 25 and 0 and 0. Probably the output will come as 5 0 0, something like that. Okay, obviously divisible, it's not divisible by this, so that way. But yeah, it will be like 5. I just need the output 5. I don't care about these 2 other numbers over here, so I'm not interested. That's why I'll put 0 0. So that's why same thing we will be doing with pop 14 and 15. That's why we'll be putting pop R14 fake. So we'll just copy this same thing over here and enter the pop R15 fake over here. Okay, and just enter this thing as 15. So these are just the comments, okay, by the way. I hope you guys know these are the comments I'm entering just to make you all understand. If you all cannot follow it, probably looking at it you all may understand. Okay, so we have pop R15 fake, pop address, we have these things done, pop is done. Now what we require is we require another thing, that is your test address, so that we'll call that test function. Okay, so once this thing will go, it will return. So it will return and wait for another function. It will return to the RSP, I guess, and it will wait for another function to be called. Okay, so once this is entering return, it's as simple as you're adding this, right, and then you're doing something like return or something like that. Okay, probably it will be like some for loop. If this is equal to this, return. So probably it will end that particular thing or something like that. It will come out of it, so that way. So return, probably it's mentioned like return 0 or something, but yeah, just it will, in short, it's gonna return and come out of this pop R13, and we can add some new address or location which we want to execute. So we want to execute this test command. Okay, this test command after return. After return, execute this thing, this test command. Okay, so just keep it neat, otherwise it may get confusing. So this is what we want to do, the test function over here. So let's just copy this value. We'll enter something like test function. I hope you guys remember what that test function included. So that was this entire thing over here. Okay, so till here, till this R15 and everything, we are just saving values in registers. Till now the exploit is not complete. Exploit will be completed only when you run this test function, and this test function will already have the preset values over here, and one on one it was going to execute and then go to R13. So we'll look into that as well. And we have, if you guys find it too too much information or something, you all can probably pause the video, analyze things, understand, and then do it. Obviously I'm going to complete the video in like some time. It's like, it's not, but then you all can obviously pause it and understand it, try to see why this thing is happening, try to analyze if you all don't follow. And but yeah, I'm sure that you all will be able to understand things. Okay, so we have the test function, so we'll be like test function to call to execute R13. That is, the system is written over there. Why? Because over here we are writing system to R13, right? So we are calling the test function to call and execute R13. That is the system. Okay, so I think we are done over here. Another thing is the final payload. Final payload, we can probably enter something like payload. And first thing we require is the junk character. So we'll take that plus, then we'll require bin sh. We'll take that, we'll enter plus, and we require pop address. So we'll require this because after first thing we are entering the junk value, then we are entering bin sh in the RPB register as we saw earlier. Then we are entering pop address to write that RSP with pop address. So that pop address, that whole function, right? This function will pop up. Okay, so we are writing this, and after that we will be I think I'll just copy this thing, it will be easier to read and understand. So this is what we are copying this pop R13. So once you call this pop R13, this entire thing will come. So next thing is you have to give input for R13 so that we pop that and we save that whatever input we are giving into this R13 register. So we are giving the location of system R13 because we need to execute that system command which we had seen earlier. Then we need to give pop R14, but we'll just give it null. So we'll just give this fake command. Then we need to execute this pop R15 over here. So then this is R15, copy this R15, and then plus we will give the test function command, because once it returns we can give another address, that is this, for the test function to execute. So what we'll try to do now is we will just try and enter this test function over here. So just enter test function, because after this it will return and it will call for the test function. Now what we can do is we can write this payload to a payload txt file or something like that. So we can just mention like write to payload txt file, write payload to txt file, payload to txt file. Okay, so we can probably create a new variable that is like the txt file, just create txt. Okay, and we're just creating a new variable, and then we can use open over here. So I know that open txt, this thing file would not be present, but we can probably just create and try to create this particular file. If it is not present, by default payload txt, and then we can give the mode as well, that is the write mode and the binary mode. So we can give this thing, W is for write, B is for binary, because these binary things are used over here. Okay, and also we'll be giving txt, and then we'll be writing this variable txt file, which is this particular file. We are writing something over here that is our payload. Okay, another thing what we can do is we can even print this particular payload just to see what we did create. So we can do print payload over here. Okay, as simple as that. Okay, so what we'll do is next thing we'll just try to I think chmod 744, that exploit py file, and then later on we will try to run this particular exploit py. So we'll be doing python 3 exploit.py and run it. So if we see over here, we get this binary and we get this 112 A's probably, and we'll get sh, then probably we are getting this null byte, and we are getting this additional data whichever we have entered over here. Okay, so this is what it was over there, and what we can do is we can check run this particular my app again using GDB. We'll set that parent mode, that is this, and also we'll be running the file by giving the payload txt, that whichever file which we did output, right, the payload txt from our exploit py over here. So we'll be outputting that. So let's just run this and see what happens. So if we do run it, in short it says no such file or directory, but obviously we get some hint that we are successful at few things. Firstly is that we wanted to write R13, that obviously we did not fail, but we did not get RC over here. As I mentioned earlier, in GDP you're not going to get it, we have to do it in the attack machine, I guess, sorry, in the other console outside GDB. And we see that we had written RSP as well as RPB over here. Okay, so RDI is obviously some different value, but we'll look into it in a bit. So what we'll try to do is I'll just try to quit again. In short, this bin sh was written to RSP or something, and R13 was written to this. So it looks like this thing worked out really fine for us till here. Pop system to this R13 register, we did write it to R13 register. This worked fine. R14, R15, I think it is 0, 0. That also worked great. And then later on we are calling that test function over there. The test function. That is not present in the RIP. It should be present in the RIP, but we'll just look into it in a bit. So what we'll do is we'll just quit this thing, and we'll just set that parent mode again, and we'll enter a breakpoint in the test function. So whenever this particular application, entire thing, goes in the test function, that means that time this whole process of the exploit will start, right, whenever it goes inside this test function. So we'll just try to copy that location of test. that is this particular thing. We'll just copy this and we'll just add a breakpoint, that is break, and I think we have to add this asterisk over here, this thing. So we have set the breakpoint at this test location, which is for that test function. Okay, so this is for that. So I'll just show you all what will happen in that breakpoint. Obviously it will come to the test function and it will stop. Okay, so now run this particular file with our payload txt. Okay, so we did run it and see what happens. So we do run it, and we see few things over here. First thing is we successfully wrote the RPB register, that is bin sh. Okay, just ignore this RSP for now since it is blank, because obviously we have moved to a new function. So probably it will be blank. We'll just see in a bit. For now, bin sh is written with RPB. Okay, so we wanted to write bin sh to RPB, that is successful. This is successful over here. So probably we can enter this thing in over here below test function, don't get confused. I think it looks a bit messy over here, so probably just consider going step by step. So we did already execute this thing. Obviously why? Because this thing worked and we did enter bin sh to RPB. This thing was successful for us. Okay, so that was successful. Second thing what we wanted to do was write this pop address, call that, and write pop13. Now obviously pop address would not be present over here in RSP because RSP value would have changed, okay, because we are already in test now. We are not over here, we are over here now, okay. So because I had set the breakpoint over here on this location. So if you all want, you all can check out other things step by step, but it may take a lot of time, I guess. So we have this thing over here, okay, bin sh. What we can check is if our pop3 actually worked. So if we look at R13 over here, R13, so it says that system function is present, the system command is present over here, okay. So this is what we wrote, right, the system over here, this is what we wrote in R13. We'll be writing system to R13. So this is what we were doing over here, and this is what we got. So we did get this, we did write system over here, so same address, okay, if you guys see, it's the same address. So we did write R13 with the system address over here. Second thing is we had to write R14 and R15 with zeros, that is the null value, and R14, R15 will have null byte, will have null value. So we have written this two thing as well. So in short, we can confirm that this part of our function worked really great and this pop address worked too. That's why we had system in R13 and all these things. Okay, so now till now it is fine, and if we look at the register over here, we at the arrow, sorry, we are over here, stuck over here. We have not yet executed this particular push RPB. Okay, if we look at RIP, okay, so RIP is like a EIP in 32-bit. So that means it's going to, what's the next register to execute? Okay, so it will be like, obviously if you are doing something, some task, suppose if you are doing enumeration, first thing what you are going to do is run auto recon, just consider example. Second thing is check full TCP and map scan. Third thing is check out the open ports and services, check out the version number. So what's the next step you are going to do? So what this application is going to do, next step, that is your 401152. So that's the next step it's going to do. That's present in the RIP. Okay, so that's the next function it's going to take. So this is the next function, and the next function over here is this test one. So this is the same thing which we see over here, push RPB. So now RPB is this. So if it execute this command, RPB will go to top of the stack and probably write this RSP over here. Okay, so this is what we want to look for. So we'll go to the next breakpoint. Okay, so hopefully this is clear. If you all have, if you all are getting confused, you can go back a bit and see how these things are working. So if you do SI to increment, so if you increment one value, so you go to the next step. So now you see that we did successfully do push RPB to the top of the stack, and our RSP earlier was 0. Okay, if you all want, you all can check out over here, RSP was 0. And now RSP is written with bin sh. So this is good news for us, because first, okay, let's just look at the test function here. So the test function, entire function is over here, which is important, that is this. We wrote RPB, we pushed RPB, now RSP has RPB value. This next function is not going to do anything much because we already have RPB as bin sh. So it's going to copy RSP value to RPB over here. Okay, and this is RIP, the next function which is going to execute, that is test1 over here. So we can just enter SI. Just main important thing is over here that we have written RSP with bin sh, which will be useful in the next register after this RPB bar. So let's just do SI again. So obviously it was like move RSP whatever values are to RPB, and this is done the same thing over here. Okay, obviously earlier RPB as well add this bin sh, but yeah. So we can just ignore this. Now the next step over here as per RIP is this move RSP to RDI. So this is the important step which we are looking for. In order to execute this R13, in this particular jump R13 step, we have to actually have this RDI over here with the argument bin sh. We need to have this thing over here, because as per the registers, I have not created it myself. If you have some R13 register or something, the command over there, so the argument would be this RDI, then I think RSI and other, there are some other as well, I'm not sure, I don't think RSI, but yeah, other registers are there. So in short, we need to add RDI. That's what our main focus was. That's how we gave bin sh to RSP. And then later on, now RSP will do the job. It'll be like, hey, you know what, RDI, I will give you bin sh. So this is not yet executed, okay? We are stuck over here before this. We will execute this and we will look at RDI. RDI is 0 now. So let's just see what this will do. So let's just do SI. Now if we see over here, obviously we'll be jumping to some another code, that is your system. Okay, so we'll jump to that. But what we see over here is we have successfully written bin sh as well. So that means we obviously did all these things over here, and we have already written bin sh as well over here. That is, sorry, not bin sh, RDI as well. Okay, so RDI is written over here. Now if we, this jump 13 would happen, system would take the value or, the argument. Like as I mentioned over here, right? Just consider sh as, sh, who am I? Okay, sh, I'm not sure. Bin bash C, who am I? Yeah, so in short, this is the command, okay? Just consider this as system. And this is who am I. So this is the argument. Just ignore the C switch for now, because that's the command which you're going to give. This is system, this is the argument. So system, which is present in R13, is going to read the argument from RDI, that is bin sh. Okay, so this is what is happening over here. We have successfully done RDI as bin sh. Now if we run this thing, obviously it's going to jump out to something else. I don't think we'll be getting all these values as well. I think it will be a bit tricky now to see other things. So obviously it says, I think over here RDI, so it goes for RDI, right? So you get some sort of understanding over here what's happening. Okay, so we did do that, we did jump, and obviously now the next command is system plt, all this thing, and it's going to probably take this RDI value, because it's going to jump and it's going to take this RDI value. Okay, so in short, I don't think after this it's going to work. Don't think things are going to work properly. But yeah, so that's how it was for the understanding part. Now what we'll try to do is, we'll just try to close this thing for now, or we can leave it running. We'll go back over here, we'll run my app, and we'll wait for who am I, echo back, and we'll probably need to enter that payload txt. In order to do that for this particular thing, we need to do it in a special way. That is, first we need to cat that payload txt file and then start cat again, so that we get that interactive thing present over there, and then pipe it with this my app thing. Okay, we need to give this cat, because if you do not give it, we will just see in a bit what will happen, but let's just do that. So if you do my app and then hit enter probably again, it says what do you want me to echo back. It will be like a and bin sh. But after this there was buffer overflow, and we did not get segmentation fault as well. So now if we do who am I, we get Kali. That means we have successful remote command execution done. That means we did overflow, we did successfully exploit ROP, and we did get successful RCE. What we can do is, after we close, we get that segmentation fault, which we can ignore. So if you just do cat and try to put that output over there, it's not going to work. Because it's going to close that file immediately. It's not going to have that cat interactive mode on. So that's how we have to do it. Okay, or you have to write a exploit file which will have your connection and everything done. But this is a bit easier way to do it, I guess. So just do this cat my app and get the RC done. Now instead of my app, what we'll try to do is we'll just go to NC 10 10 10 11 147 and the port 1337, because that was the port where this my app was running, right? Which we saw in the full TCP scan as well. Okay. Do that and see if we get something. It says average, just hit enter once and just hit who am I. We see that we have successful remote command execution. We can just check host name and we are in safe. So this is what it was. We can do LSLA and we get RC over here. Okay, so if we go to CD home, we are over here as user, so we'll do CD user. User is the name of the user. Well, okay, so we get our user txt flag as well. We can very well read it because we are over here as user. Okay, another thing is we see few things, interesting things over here, which is already present in the home directory. After we did a lot of work, probably they just said like, hey, you know what, have it in the home directory itself. So we have like a my password kdbx file, which we can probably decrypt. We have seen it in the previous Jeeves video as well. So we can use that. This is the my app, I think, which is, oh, you know, the whole buffer flow thing happened. And we have SSH directory as well. So probably we'll have SSH login. We'll try to create an SSH key pair and we'll try to transfer it over here. So what we'll try to do is we'll just, I don't think we'll cover any of these things anymore, but yeah, we can just try to create an SSH key pair. So that is SSH keygen. If you go to this, you can probably check one more thing. Okay, so you can just go to SSH and see if there are pre-existing keys present, but nothing is present. So we'll have to create an authorized keys file over here so that we can SSH into the box. So we'll just close these things what we do not require. SSH keygen, we'll type RSA and also the bytes, that is 2048 bits, sorry, not bytes. Do that, saves, enter file in which to save the key. So it mentions as this thing, so I'll probably mention something like probably mention an exploit directory, mention exploit directory and mention ID RSA. Don't enter any password, I just don't want to enter anything, just enter. This is what we got the ID RSA and the ID RSA pub. I hope you guys know about SSH, how to create this pair and everything, but we just created an SSH key pair with private and public key. So important thing is over here the ID RSA pub. So we need to transfer this or rename it to authorized keys. So what we'll do is move, so that is rename mv ID RSA dot pub to authorized keys. We can do that, and then later on we can, yeah, so that's it. We do that, and over here below we'll just start up a Python HTTP server, because we'll transfer this authorized keys file to our attack machine over here. The limited shell, right? I need a shell upgrade, and there's no Python also present over here. I don't think Python is present. Perl is present, I guess, in this box, but there is no Python present. So we can just I need this SSH connection because I need to get these files over here. Okay, so we can get it from this SCP after SSH easily. So I'll just start up Python HTTP server to transfer this authorized key to the target machine. By default it will run on port 8000. If you want to give some different port, you can give it after this server. Okay, so we'll get for this authorized keys file, and we'll go to, I think we are in SH itself. So we'll just do wget 10.10.14.28. That's my attack machine's IP address, and we'll get the authorized keys file. We do get it, we do LSLA, we have the authorized keys present over here. Now the second thing is what we can do. We have that authorized keys. We'll SSH into the box. Just go down. We'll SSH into the box and we'll give the identity file. Before that, we have to chmod it our private key to 600. So we'll give ID RSA and we'll, yeah, that's it. Our ID RSA is our private key and this is our public key. So we can SSH. I is the identity file or whatever file you want to give. So that is the ID RSA. And the user, that is user, not Kali or anybody, not our user. The user you want to enter as, that is this, who am I, right? Because it is present in this directory. If you do pwd, it's present over here in the user directory. So that's how we can log in as 10.10.10.147. Hit that. And we are over here in SSH successfully. If you do who am I, it's much better. And we can use SCP over here as well. So what we'll try to do is, I don't think we require this Python server anymore. So we'll just close this thing, start SCP. What's happening? Okay. So we'll just start SCP. SCP is secure copy. Once you have SSH connection in shell, so you can transfer files, right? So we'll just try to do, LSLA. We'll try to get these JPEG files over here. Obviously you can do sudo L and everything, but we do not get anything over here. But so this is what we are looking for, and we have spent a lot of time in the buffer overflow. Let's just see what this is. And yeah, so we have SCP. We can do the same command as SSH, ID RSA, and then user, and 147. Then give the file name, that is, I need all these JPEG files, right? So what I can do is either I can enter ing and enter the star mark, or enter something like star. That means all the files whichever have like .jpeg and .jpeg over here, and this dot is, that means it's going to copy all the files in the exploit directory. Just do that. It's copying one file so that all the files come. I don't have to manually enter one thing. Okay, we do get this file over here, that is all these files. We can look into it, but these are just images over here. Nothing great, nothing useful. You can check this out. Nothing useful over here. Another thing is the main crucial part, that is the KDBS file. So let's just copy this particular thing over here and let's just do the same thing for KDBX and save it. So we got the KDBX file as well. So KDBX is nothing but a keepass file. Obviously you all know what JPEG file is. And if you look at file KDBX, my bad, the file name is my passwords KDBX. So it's like keepass database 2.0. So KDBX is 2.0 database pass. Okay. So it's it's like a database file, and it is probably encrypted. We cannot open it directly. Okay, we can just use, we require two things over. Okay, so if we want, we can use John. Okay, keepass to John. There's a thing called keepass to John. I think it's present in the Kali machine itself. I don't think I require to install it. We can do keepass to John. So we can use this particular application tool over here. And if you hit enter, it says enter key file or the KDBX databases. So the KDBX databases, you can probably enter this and the key file which is present. Okay, so and earlier we had seen that once, in the video, that KDBX file was present, but we did not require to give any key file. But since all these JPEG files are there, and I had to try it out myself, I tried it out first, this thing, and I just did my passwords KDBX, and it probably outputted to #1. But and then I tried to run John on it to crack that particular password, but it did not work. It was running for a long time. So obviously you have to give a key file, and you can give a key file for all these images present over here. So now I have already done this box, and I know there are like 5 images. You can try to add a for loop over here and do like for I for this particular file, and try to do it or do it manually. But let's just look into this image thing, obviously, because I think, yeah, you can do it manually, like for all the boxes. There's nothing significant. You can just try doing it for, like, just take the key file and probably just enter something like this. Why didn't it copy? Okay, do this and create an hash file. So it will just generate a hash file over here. If you just enter the same 447, so it will generate a different hash file over here. If you see, it's a different file, right? So you can do for all these files over here and run it with John. Okay, John, and give a ROCU password list. So we'll just go with this 457. So we'll just save it into a file. We'll just give this arrow switch so that we'll save into a file that is probably hash 547, just mention that way. We do that, and then later on, obviously, if you do cat hash 547, it's going to have the same thing which was over here. Okay, we just saved it to a file. Okay, now we can locate ROCU txt, and we do not require this as of now, but we require it later. We'll do ROCU txt, and we get the ROCU word list, and this is the password cracking word list. I think it's present first in the tar.gz. Hopefully you all do unzip it to ROCU txt. So now what we'll try to do is we'll just try to run John. So we'll be using sudo John, or we can use hashcat as well. So I'll just use sudo John. And another thing is, again, I'm using this file because probably there's something over here. You can check it out for all the other files as well, for all the other JPEG files, but just do it quickly over here, sudo John, and we'll mention, there's nothing interesting looking, like I did not see 47, I'm like, oh, this is the one. I did try all this thing, but this is something interesting to look for later, I know that, so that's why I'm doing it over here. So we add John, we'll give the file as hash 547, and we'll be giving the word list, that is the ROCU txt word list. So if you run this, give the password for Golly, that is my attack machine's password, and it says password hashed already loaded, because I did already execute John over here, so that is present in the database probably. So it says no password left to crack, but you will get a different output when you run it first. So okay, it will mention that password over there present. So if you just do show now, so if you have to do show, it will show you the password, that is, this is the password which is present, and my password actually is the file name of this kdbx file, so you can ignore that. This is not the actual whole password. So we have this password present as well. What you can do is just check for keepass online, because I do not want to install keepass over here, so I just saw an online keepass file, that is a key web, I guess. So you have to go here and go to online web. Yeah, so we do already have some file over here, so probably just remove this thing, close it. Yes, okay, so I did try to open it. So try to open this file. Let's just go back to get the my password database. So it says something like some error. Obviously it's not a best practice to upload your keepass database online, but yeah, we are just doing it for the HackTheBox machine because the passwords over here are already like compromised or something. Okay, so we have my password. We need to enter a key file as well, so that is JPEG, that is the 5471, because we got that password right from this thing, and we enter the password which we did find over here as well. Copy and then paste it. So it requires, like, there are multiple authentication. First it's like you have to give a key file and give the password for that as well. So just press enter, I guess, and we come over here. We have just one password, that is root, and we have the password. So let's just copy this and let's just try to SSH into root. Obviously you get a password, you have SSH present, why not, right? So SSH into root 10147, you enter this and we press this. So we press this again, obviously that's not the password. You're like, oh no, after doing so much we got a wrong password, right? But obviously you get a password, you have SSH over here already as user. What we can do is we can just do su, we can just enter su, I guess, so you can do su root. So you can just enter something like su, paste the password which we did find, and we are over here as root. So if we go back to our root directory, we get our root txt file. So this was the box, and I know it was a bit difficult, tricky, but I think, as per me, I think I liked it very much. The buffer overflow part, I learned a lot in this box, and hope you guys learned as well. So if you guys liked the video, do give a thumbs up. If you all have any queries related to buffer overflow or anything, ask me in the comments below. And yeah, do subscribe for more upcoming videos. Thank you.